So, welcome everybody. I think yesterday's event a little bit cut our participation, but I think that this is a very important session nevertheless. We will have a very quick set of 8-minute presentations, each presenting use cases, demonstrating the added value of EOSC. My name is Ari Asmi, I come from Research Data Alliance. And as I said, we will have 11 presentations, just as a guideline for the speakers. Hopefully you have some time left. So if there's time left in your 8 minutes, we can have quick questions and answers. And the next speaker, when the last one is finishing, please move next to the podium so we can move straight to the next slides. I just give you a very brief introduction about use cases. Often, people build all kind of fancy things and then they show it then in the very end to the users and you see what happens. They just simply ignore those ones and they don't see the benefit of the thing presented. And the whole point of use cases is then to find out what the users, users can also be institutional users or something like that, what they actually need and use. And then you test these ones in a nice controlled way. And then you can kind of use those experiences to build other things which are also attractive to different kind of users. So that's my background slide of use cases. Let's see what kind of catnip we have found in our presentations. And I would like to ask Alberto to come as the first speaker.
Okay. Thank you. Good morning. Okay, I'm Alberto Azevedo from National Laboratory for Civil Engineering in Portugal. I'm one of the creators and developers of OpenCoast. I'm here to present you this service that was developed under the scope of EOSC and EGIS projects. So why do you need these kind of tools? Similarly to the weather forecasts, these kind of models can help us to anticipate contamination events in the coast, support emergency actions, support economic daily tasks from many kind of the activities like aquaculture or leisure and recreation such as surf or sailing, and also to guide the management to minimize the risk in coastal areas. For instance, in our institute, we implement ports and marines or study the erosion in the coast. These tools are very useful for us. And another thing that we use this is for the new idea of the digital twins. We try to, since we are focused on the coastal, we are building the coastal digital twins, which is a digital representation of the reality, but not just that. We want to create scenarios. We want to empower the user. The users can build their own systems. So this is a nice tool to create these digital twins. This is our environment. The tools that we are building. We use the digital infrastructures for the computational part that are used to process the data that we acquired from the many sensors, satellites, drones, video cameras, low-cost sensors. We use our knowledge, our models, our methodologies to process that data. And with that, we construct services for the users. In this presentation, I'm talking about OpenCoast. It's a modeling, circulation modeling tool, but I'm also the coordinator of WARSICA. WARSICA is a Earth observation service that was developed under the EOSC Synergy project also to detect water in the coast. So with these services, we try to support the managers, the companies, the researchers to deal with the problems that they encounter in the coast. We also would like to support other actions like the United Nations Decade for the Oceans, that we are going to use these tools to study that, and also the Earth System Modeling Framework that was developed by NASA for the digital twins. So this is a tool to integrate that. So what is OpenCoast? OpenCoast is a web service that the user can access via browser, and each user can have the ability to set on-demand circulation forecast system for that region. So he chooses the region, he chooses the forcings, and he has a forecast system. In the past, or traditionally, the institutions set their forecast systems. The national institutions set their systems, forecast systems. Now we want to empower the users to set their own systems. The coastal managers, everyone can set their own systems. Every day, the users get the forecasts for water velocities, the circulation, wave parameters, oceanographic variables like salinity, temperatures, and if they choose the quality model, they have also parameters for water quality in their simulation. And they get those simulations for the following 48 hours. Since we follow the data standards for the inputs and the outputs, it's very easy to create new functionalities with the service and connect this service with other ones. So if the users allow to disseminate their results, we could connect the OpenCoast to other services and create ensemble analysis or for instance, we are connecting OpenCoast to Warsica to get the level for the coastlines that we detect in Warsica. So it's an example. With the EOSC played a major role in our development because we had to rethink all the architecture of the system, because the system should be able to migrate from cluster to cluster, to infrastructure, use several IT core services from EOSC. So this adaptation enables us to globalize the service. Everyone in the world can use the service. So another thing that we managed to do is this restoration of the software enable us to open the code. So everyone that wants to use OpenCoast in their facilities, they could download the code, instantiate the software, and use privately. We are doing this with NOAA. NOAA is installing OpenCoast in their servers. They are going to use our backend to use OpenCoast. So EOSC played a major role in this development to prepare the code for all kinds of infrastructure. This is a vision that we use software from EGI. The first one, the operations to instantiate the service. Then we use some applications like federate authentication, the Dockers, databases. We use also the computation. The service can work in HPC or cloud, and we have the data services. To finish, this is a new service to empower the users. The users can make the simulation themselves. It's a very flexible service that can build for different forcings, new forcings and processes, and also models. We can install other models. We can abstract the users from the complexity of the computational part. They don't need to have computational resources. They could use the EOSC. And EOSC is a very important part of this development because we use the infrastructures and all the core service that they provide us. So thank you.
Thank you very much.
Have time?
Please, the next speaker can start to get there. But in the meantime, we have time for a very short question if anybody has something immediate burning in mind. No? Oh, there. Okay. Very short.
Very short. I saw that you're doing this on EGI-ACE, but EGI-ACE is a project that ends in not too long. So what's going to happen with this setup after EGI-ACE is gone?
We are searching for financing. Our institution needs to apply to research funding to develop the system, and then continue building these infrastructures. But we are connected to the Portuguese infrastructures, and we will manage the service from Portugal. So we are searching for new funding, but continue with the funding in Portugal. Yeah.
Great, thank you very much. And next is Baptiste Cecconi, sorry. Please.
Okay, so I will present you some developments that we have done at the Observatoire de Paris in France related to EOSC. So in the, I would say, past decade, there have been a few projects linked to EOSC at the Paris Observatory. Here I list a few of them. So very recently, and it's still ongoing, there is the ESCAPE project, which is a cluster for astronomy and particle physics. And so, for instance, here there is the Cherenkov telescope array team participating to that. VAMDC, who was funded in FP7 and now is using EUDAT services. And I will focus on the last two, the Europlanet 2024 RI, which used technologies from EOSC Hub and Géant, and Nénuphar, a recent radio telescope using B2Safe service. So at the Paris Observatory, we convinced the head of the observatory that EOSC was really a strategic thing, and so now we are a member of the EOSC Association. So in a nutshell, the way what we have used are really the basic bricks. We went partly through the marketplace or through calls of current programs. And we use cloud compute, storage, and also preservation and publication infrastructures. So this is something that is not always easy for newcomers. When you go to the marketplace, you find your services that you want to test, and then you have to, there's a one-to-one interaction with the provider to discuss and configure the service. And then there's also last thing that we've been using is the authorization infrastructures, and we use the EduTeams one. So the first example is the authorization and authentication infrastructures. The idea of that is to have a service that is a manageable registry with users to which we attach roles. So as an administrator, I administrate a virtual organization and invite users. They log in with their preferred identity providers, and then I assign them roles in terms of groups. And then in my applications, I can configure that so that people, when they log in, they get the role that are attached to what I've configured. So it's very efficient, it's working very well. So we have used the EduTeams AAI for the Europlanet program. So Vespa is a work package which is dedicated to data discovery for solar and planetary sciences. And we needed some way to grant roles to users to access code repositories, service configurations, things like that. And so we use the EduTeams AAI for that. And so just one example, on our GitLab repository, the users can log through the EduTeams AAI, and so they can enter the system and access the development repositories. So there are three basic, the three main AAI, as far as I could tell. I think I'm missing one. There's four, which are the one from EUDAT, the one from EGI, and the one from Géant. And there is also the Indico IAM that I didn't list here. Second example is compute virtual machines. So this is a service from EGI, and so we answered to a call for the early adopter program of EOSC Hub at the time. And so we had a lot of support from EGI with a very efficient Shepherd. And the service is continued after the end of the project because it's a small resource. And so we manage the access through EduTeams, which is not the EGI AAI, and it's interoperable, it works well. And so in our system, in the AAI, I have a group, which is the admins for the cloud system, and those users have access to the configuration interface of the cloud virtual machines. So this is access through tokens, and we have an online how-to tutorial to to show how to deploy this. And so this is in the frame of the Europlanet program, where we needed to host interoperable data distribution framework for small teams who don't have IT teams locally, so that we manage the server and they just have to focus on the data they put on the data distribution framework. And it's a small virtual machine because it's a web server, and we could get a dedicated public IP for each server. The third example is cold storage. So this is based on B2 Safe. And we went through the EOS DICE project, which is funded by the Commission and still ongoing. And the goal was to support communities for services, and here it was cold storage. So we had a dedicated discussion, rather extensive, to select the right solution, and finally we got 3 petabytes of storage on tapes located in Germany, and we use iRods as the protocol to transfer data. And the current stage now is to discuss the discussion on the sustainability. What do we do after the end of the DICE project? And so this is an interesting discussion. And so the project itself, so we have a radio telescope that so it's the end of the commissioning phase now. We are opening the radio telescope to open calls, and we are producing a lot of data, and in the end the reduced data is of the order of 1 to 2 petabytes per year. So we are building the data center, and one piece of the architecture is the cold storage for backup, and at the time it's the B2 Safe storage in Germany that has been selected. So in general, in the science of the universe for EOSC, this is something that, well, fair and open is something that has been there for a long time, either in astronomy, space physics, even earth science. So this is not something new. It has started in the early 2000s in most of those communities. There are many programs that are there. And also, there are many, as I showed, projects that are using EOSC without being directly funded by the EOS programs. So that shows that it's working, but it's really under the hood, so nobody really see it. And then just the last word on the various support opportunities, and I think that's very important to show this. So I listed a few that I could find. It's not up to date, it's not complete, and there is really a need to have a place to find those open calls. That's something very important for the community.
Great. Thank you very much. You are exactly on time. Thank you. And that was very interesting view from the institutional view. I would like to ask the next speaker yeah, you're already there. And in the meantime, we can have, if anybody has a short question. No, I don't see so. So we can continue then. Thank you.
So good morning, everybody. So in this use case, I will be presenting you the effort to build a climate indices dataset for climate change impacts assessment. And this has been done within the EGIA's support call and using EOSC resources. So to explain you the motivation for this use case, I will show you how the climate data is distributed to really show you the great motivation we had in this use case. So the climate data is distributed using the Earth System Grid Federation, and it's a federation of data nodes located throughout the world. And the data nodes interface is really not straightforward to use for non-expert users. We have a screenshot in the lower right-hand side. And what is available in those data nodes are variables that are output from the climate models themselves. So we have basic variables for the atmosphere, the ocean, and other variables. So it can be temperature, humidity, or precipitation. And at different time frequencies, it can be daily, it can be monthly, or yearly. And this is what is available for users to assess climate impacts. So there's a gap between the user needs and available data, because those standard variables are great. It can fit to some of the needs of the users. For example, if you are looking at the temperature change, it can be suitable, but even then, if you want to assess the climate change anomalies, then you need to post-process this data. So you need to calculate some average. You need to over specific regions, for example. You need to calculate anomalies. It means that you need to calculate the change between the future climate and current climate. So you need to post-process this data. And also you would want maybe to evaluate the climate extremes, and this needs even more data processing. We cannot use those output as they are. And under this understanding climate change impacts, so you may need also input data to impact models. So some user stories that could be interesting to show, those are really examples on what users are doing with climate data. So if you want to compare the future climate compared to now, you could ask yourself, will there be more droughts in northeast Spain in the future? Or how likely landslides will occur in this valley? Or which region in Europe will see the greatest change in heat wave intensity and occurrence? So those are the kind of questions users want to answer for the society. So to do that, one of the tools we have for data analysis is a climate index. Climate index is derived from basic climate variables such as temperature and humidity, and you can compute things like the number of warm days or the number of summer days or other climate indices related to the basic variables. And most of those indices are standardized within the international community with metadata standards and also the standardized definitions. So the project for this EGI use case is to pre-generate 50 standard climate indices on all the CMIP6 simulations. So this is quite a challenge because the amount of data and the amount of simulations is very high. And what we decided to do is to process the core set of simulations to start with. And so this calculation is done on all the climate models, all greenhouse gas scenarios, ensemble members, and all different versions of the data sets. So we need daily time frequency as input, and then we output at time frequencies that can be seasonal or even for the whole future climate. So the infrastructure we use for that is the INES data space. And the INES data space provides us an interface, a Jupyter Lab interface. So we have notebooks. And then the development of the workflow was done using notebooks and then converted to Python scripts for execution in this environment. And all the input data has been made available into the INES data space. And so there's a synchronization between the ESGF data nodes and the INES data space to provide what was needed for this project. So it's a tool called SIMDA that synchronizes the data that we need into the data space. So the timeline, we are in the process of computing all the climate indices, so this is still in progress, but it is progressing well. We need to validate all the calculations at the end of this year, beginning of next year. And we need to decide, because EGIS will end, also where to store this database, because we want to make this available to the whole community. And so it can be stored in NetCDF, ZAR, in commercial public clouds. And we want to make that accessible within the EasyNet Climate for Impact platform. So this is a platform we have been developing for several years within the climate community, and EasyNet, there's a project called EasyNet 3 that will be ending in March. It's a H 2020 project. And this database will also be used for the digital twin for climate. So this is linked also with what was shown in the first presentation. So we also work on the digital twin, and we do this work in the Horizon Europe Intertwin project. So we also need to disseminate about this climate indices database for users to be aware of that. The possible extensions are reanalysis, Cordex are regional simulations, SEMI5 the older global climate simulations, and the future one, SEMI7, and the future Cordex 2. So I will end here. I don't know if there are questions.
While the next speaker prepares, we have time for one question for Christian. Again, please.
Well, that's what you get when you're looking into the sustainability of EOSC, I guess. So I find it fascinating to see that we have now had 3 use cases, and they're all doing really interesting things, right? But it's all based on temporary project funding when it comes to the resources. So I was wondering, listening to you, so what's your strategy once EGIAs runs out? So where are you trying to get continued?
So the calculations will be done at least for SEMIP6. So we have this database for users. Where we will store it, it's not decided yet, but we will find resources within the climate community, or it could be also on ESGF, because I'm involved also in the ESGF executive committee. So we can also have we can plan for having a new database that are different from climate model output. So this is the plan. So I'm sure we'll find some ways of storing this data set, because it's it bridges a huge gap between the user needs and the data.
Thank you very much, Christian. So please, next presentation about Triple project by Émile Plotier.
Yes, perfect. Thank you, Harry. Good morning, everyone. So I am Émilie Blotier, working in CNRS in France, and we have launched 3 years ago H 2020 funded project called Triple to develop a discovery platform devoted to social sciences and humanities. So the topic is a bit different from the 3 former presentations. So this platform aims at gathering to become a single access point for social sciences and humanities, let's say SSH as an acronym. And this platform is currently dealing with three main kinds of data that are publications and datasets, profiles of researchers, and researchers' projects. The platform is dealing with 11 different languages to focus also on less represented languages and not to focus only on English publications. So we have developed what we call a Go Triple thesaurus with a bit more than 3,000 concepts in each of the 27 disciplines covering social sciences and humanities. And we have also integrated what we call innovative services into the platform to help researchers to cross their research in a multicultural and multilingual environment. So unfortunately, I do not have the time to present you the 5 innovative services, but I will quickly present you 3 of them. And here you have the composition of the consortium made of 21 organizations coming from 15 European countries. So we have a various consortium made of the main ERICs in SSH that are Daria, Clarin ERIC, and CESDA. We're also working with research centers, universities, foundations, and also SMEs. So here is the main page of the platform. So of course, it is not compulsory to register. You can just go, and I encourage you, to visit the platform, gotriple.eu. And what you can see for the moment is the number of data that are available, indexed via main aggregators such as OpenAir, such as DOAG, DOAB, but also smaller repositories and local repositories, national repositories from different countries coming from Poland, Croatia, Greece, and so on. And this is an iterative process because we are currently still indexing new resources. So you have a bit more than 4 million documents, that is to say publications and datasets, a bit more than 20,000 projects, and a bit more than 2,900,000 profiles of researchers. And when you registered, you have access to what we call the section tailored for you, where the system is recommending you new publications depending on your centers of interest and your previous queries. So let's move to the main services. So concerning the visualizations, we have 2 new options that are, for instance, the knowledge map, which is a topical overview of your query. That is to say, for instance, here you have the example of feminicide, and the system the algorithm is looking at the 100 most relevant documents and then creating those kinds of bubbles with the main topic depending on your research. And then you can at a glance see what are the main publications depending on the concept you have put in the search engine. We're also having what we call a stream graph, which is a bit different because in the stream graph, if you click on the same search query that are feminicide, for instance, you can see the evolution of the research by seeing the evolution of the keywords and the concepts that are used in the publications devoted to feminicide. So this is quite interesting to study the trend of the research on a concept. We also plugged in an open annotation tool developed by our Italian partner. And via GoTriple, you have access to the original source, so the original publication that you can see on the screen. And then via the small plugin Pandit, you can highlight, tag, comment, or make some semantic annotation directly on the source, on the original source of the data, and you can decide to have those comments public or private. So if another researcher is looking at the same document and you have it public, you can then see what the other researchers have done, and then perhaps connect to him. Another service that I would like to highlight and present to you is the crowdfunding tool, because we have developed a service trying to create bridges between the research, the SSH research, and the civil society, trying to foster and enhance the impact of SSH research in society. And here you have 2 examples. We launched a first campaign at the beginning of this year to support the Ukrainian editors, and it has been quite successful because the project was funded by more than 100%. And currently we are supporting 2 other researchers from the Coimbra University in Portugal about crisis and journalism. Yes, and to conclude, because there has been recurrent questions about sustainability, of course, of the EU-funded projects. So Operas is part of the consortium. It is a European research infrastructure devoted to open scholarly communication in SSH. They are part of the EOSC association. We are currently on the S3 roadmap to become an ERIC in 2027. And this research infrastructure will sustain the Go Triple platform at the end of the project, because the project is end of next March, so we're still having 5 months before the end of the project. And Operas is currently composed of 53 organizations from 18 different countries, and it is led by an executive assembly managed by 10 members. And you can see here a short overview of the main services offered to editors and researchers by Operas. So you're having certification service, metrics service, publishing service portal, the discovery service that will be Go Triple, research for society service, and also another team working, of course, on future services to always remain fitted with users and researchers' need. And I think I'm done. So yes, you can have a look to the platform and see how it goes. Thank you very much.
Exactly 8 minutes. So thank you. A very interesting show from Triple. And please, the next presenter. But while that's happening, if you have any quick questions for Emil.
Yeah, one quick question. It's very nice that you are able to have additional information while you're searching, right, based on some algorithm. But is it easy to find how you select this additional information while you're searching? I mean, can you find how this algorithm, they call it today, works, so that you know what you're reading, why you're reading this additional suggestion of searches?
So are you talking about about recommendations, the recommender system? Okay, so for the moment, no, you cannot keep, I'm not sure it is your question, but I don't think that you can retrieve the history, the historical of all your researches. This is the point.
No, I'd like to know why the system selected these recommendations.
Okay. The idea was for the recommender system was to target better the research and publications, because you have currently new publications coming, and we thought it was interesting if I am doing research, I don't know, let's start again on feminicide. I can be aware, and I'm not perhaps aware of all publications in the 11 languages, and it can also be indexed to the several of the 27 disciplines, and then the recommender system helps me to retrieve the information. With pleasure. Thank you.
Thank you very much. And next is Fanny Adloff. I hope that was right. Presentation. And please start.
Hi. So today I'm going to present what the benefits that we expect from the component development in the FAIRCORE for EOS project, and I'll do this from a case studies perspective. So I briefly highlight the project and the developed components, and then I'll switch to the benefits before advertising what we do in the project, and see whether you'd like to use these components in your research community. First of all, so the FAIRCORE for EOS project has just started like 3 months ago. So it's like trying to give a bit of vision what we expect from this project. And so it aims at developing 9 core components to fit into the EOS core. And this is really addressing the gaps which were identified in the strategic research and innovation agenda. And it's really about improving the fair research cycle, and about improving the discoverability and interoperability of an increased amount of research outputs. So we have these 9 components. I won't go into detail. If you're interested, please feel free to go to the website stated down there. And I'll just give 2 examples. We have, for example, like the research discovery graph, and it aims to deliver advanced discovery tools across the EOS resources and community. Another example is the EOS Research Activity Identifier Service to mine PIDs for research projects, and so you can really manage and track the project-related activities. And for that, so we will have these 9 components which will be developed across the project, so, and that will reach different maturity stages. And then at each stage, they will be incorporated into 5 case studies, so, which are domain-specific. So we have the climate change case study, the European integration of national-level services, then the mathematics case study, then the UDAT one, and then the social science and humanity. And in this presentation, I will only focus on 2 of them, on the climate change and the SSH one, just because I can't take too much time. So climate change in green, left, and then the social science and humanity in right. So they are both incorporated, the components that I've listed in blue. And so what do we expect as a benefits? And I mean, expect because obviously we are the first stage of the project, so this is like a forthcoming view. So in both cases, we really expect to improve the discoverability and access to community data for other community. So it's really about fostering and easing the cross-disciplinary and cross-border research. We expect to ensure an accurate and reliable description of data, and also to ease the use by other community. And then for the social science and humanity, we expect to improve the mapping from data to tools in the switchboard so that you can really access the right tool for the data you have either uploaded or searching for. Also to improve the representation and tools capability by offering mappings from various metadata input format to a standardized form. And also offer a uniform interface from various PID systems to the metadata or resource. Just to maybe depict all this a bit better, we have a few potential user stories. I say potential because they are fake, is what we could imagine out of the components which are being developed in the projects. So for example, from a climate change perspective, just let's assume we have had an extreme forest dieback, and we have the forest manager, they need to pick a new species to reforest the region. But I mean, obviously you need to take into account a lot of different parameters. So they will need to have, like, I would say, regular climate parameters such as temperature or humidity, but also like more specific one. For example, vegetation duration, soil moisture, occurrence of extreme event, but also like even from other disciplines, like the occurrence of pests in the region. And yeah, for this, then they would have like a unique platform to access all this data and to make they collect the right data. And then we have another example, more from the SSH domain. Also, we could even have the same thing for the climate change. But let's assume we have a teacher preparing a course, and for this course, this person needs resources and tools from various depositories and can also use other sources. And by grouping these resources and tools allows the teacher to easily distribute and reference the required material. And there is also support for the version collection. So it's changes over time of the resources and tools will be also supported. And the last example, we have, for example, a researcher who has a set of resources and is interested in what tools he could use to process resources within the Clarion community. And then what he will do, he will upload these resources to the switchboard, and then he will be offered a list of tools that can be used, and just by a click, he will can send directly the resource to the tool of interest, which is pretty convenient. So these were just a few examples, so we'll see how it goes in the future. So when we integrate the core, the development into this use case, as a case study, sorry, not use case. And then just more general advantages which are expected, and I think these are shared across the different communities. That this saves time and money because the community developers do not need to make this development. It's done through the project. And then we expect also an enhanced use of the data from a specific community by other community through the improved discoverability and also the easing of the user experience and the improved, for example, improved quality of switchboard recommendation when it comes to specific resource processing. And then this will obviously also foster synergies and interdisciplinary collaboration and path the way to a potential big cross-community interoperable data platform. And with this, I'd like to finish saying that in case your research community would be interested in using the components which are starting being developed in Fairco for EOSC, please reach out to this email address down there. And you can also engage in the co-design and follow up the progress from the project. And I'm done.
Great, thank you very much. Any questions on this presentation? I think it was kind of interesting. Then you are talking about future projects, especially as the questions were usually about the continuation of the previous. Yes. No questions? So let's go forward. So Jan Meyer from SICT.
Thank you. This is also going to be a slightly different presentation because I'm not presenting a use case as such, but I would like to share the thinking process of a self-financed service provider when confronted with a new context like EOSC. So who here is familiar with the tool called File Sender? Because that's what I would like to use as an example to guide that. Okay, I see one. Okay, right. And who has used it? Yeah, that's one. Yeah, okay. Did you like it? Okay, well that's good. So for those who haven't, what is File Sender? Simple and secure transfer of files through a trusted intermediary, right? This is if you want to share something that is larger than you can attach to an email, you don't want to drop that on a USB stick and send it by postal mail, as was done back in 2010. You'd like to send it over the network. So it's kind of like a tool that allows you to better actually leverage that great capacity we have in the networks. Or translated, it's kind of like an open source sovereign WeTransfer designed for RNE requirements. So it's an open source web application, it's native in the browser, so no installation is required. It does encryption in the browser. AI is nicely integrated, it has an API, it works for 1 terabyte plus transfers if you really want to, designed for large scale use, and it's regularly security audited. So it ticks a lot of boxes. It's typically deployed on a national scale, right, through the national NREN. We know that there are several institutional deployments. I recall that Elixir has one. We know that it's used in the commercial sector and government sector, so it's pretty widely used. It's also a joint development project of software, and that's how we do the sustainability question there. So we started in 2009, and it's sustained by regular financial support of over 10 NRENs. So we have national instances in most of Europe. There are reasons why it's not happening in Germany and the UK, but I won't go into that here. We also have a certain global footprint, and when you look at that, and it's actually being used, right? So we have use numbers of a couple of countries. It's pretty popular in France, and other countries it really depends a bit on how active the local NREN is in marketing that service. But what we effectively have is, hey, we have a de facto European infrastructure for data transfer between kind of like 10 megabytes and, if you really want to, up to a terabyte, but up to hundreds of gigs. And that's quite interesting. Well, and then we're confronted with a changing landscape. EOSC, all research data, findable, accessible, retrievable through one coherent infrastructure, technical infrastructure, coherent policies, like, interesting. And then there's this marketplace of services. We should be able to do something really, really useful with that. What could that be? 1 million researchers, hundreds of aggregators, thousands of organizations, 40 countries, and then one coherent thing to get to all of that. So it must be possible to do something with that. Now, we've just started our journey, so I don't have the answers readily available. But I have 2 examples of things that we're looking closer at. So it's a changing environment, gives us new opportunities. Because we're self-financed, we always have to think about, right, how can we improve on our stuff? How can we stay relevant? And when EOSC comes along, well, yeah, that forces us to think about that, because if we're not EOSC relevant, unless EOSC fails, and it's a bit too big to fail, we have to be relevant in an EOSC context, because otherwise you fade out. Maybe that's good. Tools need to disappear from time to time. FTP has mostly disappeared. So we're looking into questions like, right, how do you increase the value? Are there new channels to the users? Are there new user groups? Is there new functionality that we could offer? How can we get to increased use? Because ultimately, let's see, we'd like to increase those numbers, right? That's what my management needs to know. And not unimportantly, increased value for users and more usage leads to an increase in the taxes that we can levy And I say taxes. The way that we finance things is we go to the people that depend on the tool and we say, look, this is a joint development. Would you like to contribute a certain amount of money to that? And as long as there are a sufficient number of organizations that say yes, then that actually works out. And we don't need that much. We need about, for the development, if we do it properly, 250K a year, that probably covers it. So it's not that much. And so far this has worked pretty well. So I'll give you two examples of things that we're thinking about. So one is, I showed that we now have basically not connected national nodes. So we've been toying with this idea, well, what could you actually do if you actually federated all those into a coherent infrastructure? But so far it was like, I don't know, a bit suboptimal. But once you have an EOS context to do that in, well, that actually makes it a lot more interesting, because then we can present this de facto European data transfer infrastructure for, at the lower end of the scale, through one coherent UI, reaching all the users at once. Using national sovereign backends, because that seems to be the sweet spot why people like FileSender. It's transfer of files through your jurisdiction, which means that there's a couple of worries that you just don't need to have. So it retains that value add, but it makes it easier. It doesn't really matter where you are, it just makes you get to the service easier. If we would do that, it also enables us to deploy some new functionality that we think is potentially interesting. Right? The thing that worries me is not research data that is deleted in archives, but is research data that is altered in archives and that we're unaware of that altering. Right? If you base your national policy on research data, then the only thing that Russia has to do to screw things up is to actually fiddle with the numbers without us knowing it. So doing something about sealing that data that goes into archives, well, that could be interesting, and we think we can do that at scale by slotting in the data sealing functionality in the upload stream. Because once you capture the upload stream, well, now we encrypt it if you want to. We could also seal it, cryptographically seal it, and we can do that at scale. We can also start doing things like, rather than doing person-to-person transfers, as we do now, you could do person-to-archive transfers or person-to-machine transfers. Maybe, God forbid, you could even do something like instructing a machine-to-machine transfer. So those are games you could start playing and thinking about. The other example is, given that EOSC is such a huge user base, it gives us a pretty receptive user base, we hope, for things like scalable encryption key management. That's a lot of complicated words. We have the capability to send encrypted files. The problem that is really hard to solve is, how do you do the key management? I won't go into the details, but it's actually possible to use passports for that. So there's a technology pilot currently going on to integrate that. If we make that succeed, then we have the capability for you to send encrypted files to someone else, right? And the other person uses their passport or their driver's license to unlock that. And that actually works. And now we have EOSC to actually allow us to think about deploying something like that. So that might actually lead to, I don't know, an EOSC context transfer service for ad hoc sensitive personal data. That might actually be quite nice, because that seems to be a problem. So I'll leave it at that. Here are some details if you want to contact me or us. That man in the back over there, could you please stand up, Mr. Guido Aben? Yeah. So he's my partner in crime, so you can also ask him, and that is 8 minutes on the dot.
Exactly. Thank you very much. Well, we are changing the speaker again, a chance for a very quick question from the audience, so maybe you can also discuss afterwards, but very quickly.
Well, in my institution I have a problem, because I'm a public institution. I have to support the private companies. I cannot have a business with the services that I create. All the services that I create should be freely available to the public. I cannot have money for the use of the service. So a way that we found out is to search for funding for research, and this kind of funding from EOSC and other projects. From your experience, how can I solve this problem with the business model that I cannot have for my institution? How can I
turn open cost more sustainable without getting paid by the users?
I think that's a very tricky question to answer in 30 seconds. Yeah. So perhaps we move this one to afterwards in the coffee break. So please, Isabel.
Yeah, okay. So let's go. Let's talk about phenomics data. So I will introduce you the phenotyping hybrid information system, PHYS. And that is an ontology-driven information system dedicated to phenotyping data. And then we'll see how the EGI-ACE program was an opportunity for us to deploy PHYS on the EGI infrastructure and to build a federated and interoperable infrastructure. So to set up the context of phenotyping, there have been a lot of technical improvement, progress in the recent years, and several opportunities such as EPPN 2020 and emphasis have structured the landscape and allow researchers on a phenotyping platform to access to facilities, installation, material, and to develop shared experiment. For example, to study the same maize varieties in different platforms, so in different environmental condition, control condition. And so that's when the sharing of data is really crucial. By the way, phenomics data management is a really huge challenge because plant phenomics experiments are really expensive. They require a lot of different expensive material, human resources. They take a long time. It's impossible to reproduce environmental condition that you have been 1 year. And phenotyping is the expression of the genotype in a specific environment. So environmental conditions are part of the phenotype. Phenomic information. So you need to be able to link the phenomic data you have to the environmental condition you get at the specific moment. So, and you have also images, binary RGB images, binary images, LIDAR, everything. So that makes huge and complex data sets. And there are also the problem of the transparency and reproducibility. So that's why you need to have rich metadata, and that's why we developed the PHYS information system. So to make fair data and structure the data, we rely on 2 key points. The identification, so everything in an experiment is identified with an URI. That is persistent, unambiguous, and resolvable. So you can see the plant as an identifier, the camera, the cabin, so we can identify everything that has been used. And we rely also on semantic. So with naming convention, for example, we have naming convention for the variable. You can see on the screen that the variable is built on the entity, the characteristic, the method, and the unit. So, for example, plant 8, manual measurement centimeter. And we use also control vocabulary and ontology, so we can link a variable to a domain ontology, so for example the crop ontology, the plant ontology, and formalize the relationship between the different entities using reference ontologies such as Dublin Core, FOF, or others, and also application ontologies that we build by ourselves and relied on PHYS. And we also allow to annotate enrich data with annotation. So that's why it's an ontology-driven information system. So this is a PHYS perimeter. So you can see that FIS will collect all the metadata, semantic descriptions of the experiment, the scientific objects that are going to be observed during the experiment, the factors, the sensors, the variables, and it will also collect the data and all the data files, the images, raw images, binary images that can be stored on a file storage system. So to declare the experiment and to visualize the data, we provide a user interface, a web user interface, and we provide the REST API that can be connect with R and Python package, so we can collect the different environmental data directly from the sensors, and it's the same for the phenotypic data that will be collected by field robots or UAVs. They can be treated in an image processing analysis pipeline and go straight to the information system. So that's nice, but you need to have an infrastructure to deploy this, and that's why we chose to access to the EGI services through the EGI ACE call for uses program. And so we set up a proof of concept with a demonstration instance with some experiments that were provided by the University of Helsinki. And we also deployed 2 FIS instances for the University of Helsinki and the University of Copenhagen, who are part of the project. And we want to disseminate then the services to a wider audience. So this is a schema of the FIS infrastructure, and we'll see which GI services we've been using. So this is the typical architecture, so that's why it's an hybrid information system. You can see there is triple stores that allows to store the metadata, and there is also NoSQL database to store the data, the provenance, and the geospatialization information, and the different data files that are linked to the data. And this is there is an API and web services layer that allows to interact with the different databases, the web interfaces with Swagger 2, and everything that you can connect to the web services, and the breeding API that is standard in the domain. And so this relies on an infrastructure, and we use cloud computing services of EGI to deploy the FIS instances. Then we implemented to the EGI check-in authentication that has already been presented by my colleagues. We were connected to iRods, and the project was the opportunity to try to connect to the S3 storage Amazon because the University of Helsinki is using it, and we want to connect to EGI Data Hub then too. And we deep hybrid data cloud portal also host deep learning models. So these are the next steps, data integration with the breeding API and the FIS web service, connecting to the EGI Data Hub file storage system. And we want also to allow users to build their data set into FIS, relying on experiment and project, and to deposit it on research.gov and get back the DOI into FIS. And then to make the link with the deep learning model hosted on the deep hybrid data cloud. I'm a bit short, so I will skip the next slide, just show you the 3 different FIS instances and the unified view that we want to build. And I'm done. Here's the acknowledgement. And if you have questions and you want a demonstration, I'm available at the coffee break.
Okay, great. Thanks. Thank you very much. Again, while we are changing the speaker, I would like to ask the next speaker to come here already. And if there's any burning question which you can ask in 10 seconds. Okay, maybe in the coffee break then. Thanks again. Please.
Hello, good morning. My name is József Kovács. I am from Staki, from Budapest, Hungary, and in this short presentation I would like to draw your attention to a small but powerful tool which we developed in the NANIAS project. The NANIAS project was started 3 years ago and just finished 2 weeks ago. And in this project we were aiming to develop services for three scientific areas: underwater, space, and atmosphere. And also we wanted to not only develop the services but also onboard them on EOSC. So if you type NANIAS in the marketplace, you will find all the 14 pieces of services which we have developed. And in the project, this is the project structure. 2, 3, and 4 was dealing with the 3 different areas of scientific areas of applications and services. And WP6 as an extra was developing core services. And there was 4 categories of core services, and one of them was dealing with artificial intelligence related tools and services. And this is the result of this task was the AI Science Gateway. This was a Jupyter Hub-based tool. All the basic core services related to machine learning was integrated into this. Also, it was the authentication, storage access, logging, accounting, and so on was also integrated into this Jupyter Hub. And behind there was several environments. And one of them was dealing with Horovod, which is a distributed machine learning framework. I will focus on it in this presentation. But there was also Spark cluster, there was also model serving possibilities, and even more, there were several space-related machine learning environments. And now I would like to switch to Horovod. So Horovod is an open source distributed machine learning framework. It has TensorFlow, Keras, PyTorch, and so on support in it. And it is very scalable, and it is able to run on hundreds of GPUs. And the user, after developing let's say, for example, a TensorFlow Python application, only need to add some lines to the source code, and then it will utilize the power of Horovod. There is a data parallel execution, so the training data is divided into subsets, and the same data, so each node will train on the same data, and these parameters are synchronized time to time. So it is implementing a ring or reduce strategy, and it's implemented on top of MPI. And here you can see the structure of the AI gateway. Of course, there are many environments, which is launching, let's say, Jupyter notebooks on the actual Kubernetes cluster where it is running. And also the Horovod is somehow represented as a cluster, which is a remote one. So we can install, of course, this kind of Horovod cluster in any cloud in the world, no problem, and we can simply link it to our Jupyter Hub using the SSH spawner. Once you have this nice cluster and you can access it and use it, you are also provided with some nice graphical interface to monitor the usage. It is based on Prometheus and combined with Grafana. For example, you can see as normally, you can see the CPU memory usage or GPU and so on in time. So that's what serves the user to monitor the environment. Here you can see a screenshot of the intro page, where you can see several, which I already mentioned, several environments. So the first one is about simply developing the machine learning algorithm. The second one is to train it. For the third one is a model serving environment for based on Ben2ML, and the REST 3 is about machine learning specific applications from the space science area. So once you log in, you launch your Jupyter notebook, and then you will end up in a Jupyter Lab environment where you will provided by 2 extra generated descriptions. One of them is a human readable description of the cluster which you are having at the moment and on which you can launch your applications. And also there is a host list file which is needed for Horovod to launch the training. It is based, since it is based on MPI, this file is an MPI compatible description. And once you put your application on it, and once you add the necessary Horovod lines, source code for utilizing Horovod, then you can execute it. This service can be found, as I mentioned, on the EOSC marketplace. You just simply type Horovod and you can get it. You can have access to it. First, you have to generate a ticket to request for access, and then you can get different access modes. We differentiated 3 different access modes. The first one is based on time sharing. So you will have let's say a demo cluster. We will install it on our resources. We have a huge cloud in Hungary, so we are hosting these clusters there. But at the same time, we also have EGIS resources, and we can install Horovod on those resources as well. But in case you would like to, the time which we can provide you, for example, a few weeks, is not enough for you, then you can request deployment on permanent resources. We may apply for resources from EGIS, for example, but it's up to negotiation. And the third access mode is just if you would like to install it on your own resources, we can provide you with manual technical discussion, consultation, support, whatever you need. So that was my short presentation. Thank you.
Thank you very much. Thank you, Petra. Any quick questions before we... is Carl already here? Yes, please, because he came from another session, but I see no questions, so we have a little bit of computer juggling work in this. Let me see. Okay, great, please.
Thank you. So you're a fast computer juggler. Perfect. Thanks a lot. So my name is Carl Presser. I'm working in the FNS Cloud, which is a thematic cloud, and I would like to show you the catalog app that we developed in this project. So what is the FNS Cloud? So we're Horizon 20 project. The FNS stands for Food and Nutrition Security, so it's about the food and nutrients. And we're also called the Food Cloud, which is a little bit more obvious than FNS Cloud. The goal is there to generate a first generation food cloud by federating existing and new resources. We are 35 beneficiaries from 11 members countries, and we had a 4-year project, and it's ending next year in September. And I show you here the consortium. In the food area, in the food domain, we have one of the biggest characteristics is that we are very, very much fragmented over Europe. So there are many research institutes, there are many also private food industry, and in between some governmental organizations and near governmental, and they all having data about food or databases or tools for food and nutrition. And there is very little central databases. They're very spread, so often there's also institutional repositories. And many of this data is not, you make once a study and then it's done, but they're kind of living data, right? So a food composition database, for instance, every year there is a new version with new foods, removed foods, and so this data set needs to be maintained. This is a continuous, basically, work. So one of the big challenges here, this findability with a catalog must be very big because it's very specific and very fragmented in the food area. And that's why we checked, of course, then the EOSC marketplace, but when we started there, the EOSC marketplace was not there yet. It was during the project it was developed. And also we have seen EOSC Future is now developing a discovery service. But in the meantime, we needed something for our. And so we developed the own catalogs. We have 4 catalogs basically for data sets, tools, services, and training and education. And we're kind of providing different search functions. You can see here on top that we have a simple search, very much like Google, one field, and the user can enter something. Or we have also a table search, I will show in more detail, and also an advanced search function there. If you then search for something, you're getting the results listed, very similar basically to EOSC Marketplace. And if you click on an entry, like here or on Foodcase, which is a software, we have a lot of information about the contact person, some details, some technical details, and also collaboration options, how can it be used, and of course licensing information. This is very much compliant with the EOSC Marketplace. Once it came out, we're checking that we have the same fields. We had a little bit more, but we have at least the ones from the EOSC Marketplace, so we can easily transfer our entries into the Marketplace or from the Marketplace to us. And we also worked there with the logging. So you need to log in to create a new resource, and then you can log in again to modify the resource. And what we also tried, very similar to big platforms on the web, is with the ratings. We wanted that you can log in and that you can rate the resource. So the community should rate resources, and over time this is a good indicator for new research, right? PhD students coming, searching for a resource, and they see, oh, this seems to be a good data set, or this seems to be a good tool. So we implemented this rating. To be honest, it's an experiment because we realized, okay, one rating is difficult because for certain purposes, tools, resources are better or worse. So it's kind of, was an experiment. So I'm not sure if one rating thing is enough there. It probably should be more elaborated. But this is something we learned during the course. With the catalogs, we started with a map of topics. So here you see we put all this specific topics in the food science domain on a map, so that we kind of have an overview what we're all covering. Such a map was not easy. They're currently under revision because many scientists complained that the map is somehow illogical or not understandable. And so we kind of designed still 3 main groups and then subgroups in there. And basically what we did is then we made tags out of these topics. And so you see then in the catalog you can attach this tag to a resource, and then somebody can search for food consumption data, for instance, and getting all the resources for this topic. So we're kind of try to drive the user in this way. Topic-specific tags, because then the user community said, okay, there are a lot of tags missing, not only the topics, but we need also some more information. And we used the concept of the tags. As you know, it's kind of, I'm always explaining it as a post-it that you can attach to a resource, write something on it, and then you can search after it. So we had kind of, depending on the topic that you have, we have more sub-tags there. And so they can be assigned. They only appear if you selected first a topic tag, and then you have additional tags that you can use and search after these tags. Here you can see an example as well that you see they have a lot of tags, and then you can search for these ones. What we also had a lot is a relation between resources. We have seen the discovery from EOSC Future. I was very happy to see they have the same problem because a lot of resources are connected. So they could be data sets which are collected in the same study, or you need an app, an application together with a data set, or you have some training resources and you want to connect them. And here is an example that you see a resource has a connection to different data sets. to different tools, and even there is a service connected with it, and so you're getting the better picture of what else did you need to check with the resources. So I think this is something, was very helpful for us. Then in the food science, we have a very specific characteristic, which is the food supply chain. So it starts from the farming, the harvesting of the food. It goes through different process steps. I'm showing it here, until the end where we're sitting and eating the food. So there are several steps, how the food is processed, how it's preserved, and so on. And this we have in our domain, very specific, and often this is used to find resources. So a user wanted that, can I along the supply chain find certain data set? And we said, okay, let's integrate this in the catalog that you can search along the supply chain in a specific step. Let's say you want to find there what data and tools are available. By the way, the supply chains are very food specific. So this one is for the milk, but for the virgin olive oil, we have a separate one, a much shorter one, or for an Atlantic salmon, also looks different. There we start with the fishery in there. So this is very specific, and we wanted in the search engine to represent this one. So you can search for something, and then we show the whole food supply chain and some other characteristics, and you can find data sets which are available, but you see also there is no data available, which is also kind of the research community quite interesting. I finish, just a simple search, how it works. We wanted also to be transparent there, because a simple SQL-like search is not very useful, so we went a little bit deeper and went to 3 grams, that you're putting names into triples of letters, and then you're looking how much you have in common. So a 3-gram search with the Jacquard function gives you the probability, how feasible is a search. So also, easy for mistakes. And with this, we have quite a complex URL, but with the FNS Cloud link, I invite you to check these catalogs, which are quite innovative here. Thanks a lot for your attention.
Thank you a lot. Again, a little bit of computer juggling, and because we are a bit short on time, you can ask us questions from Carl in the coffee break.
Thank you. So, welcome everybody. My name is Zoltán Farkas. I'm from Staki, and I would like to talk you a few words about how to enable the usage or the exploitation of quantum resources for EOSC users. So this is the outline of my presentation. I would like to briefly introduce you what are the quantum hardware options available today, how they can be used, and after that I would like to show you a reference architecture that we have developed at Staki to ease the access to such resources. And finally, I would like to tell a few words about the EGI notebook service integration, so the integration of this service. Okay, so the quantum computing problems are a bit different from the traditional computing. So you write code, it's compiled to something, and it is executed on the CPU, modifying the registers on the CPU and altering the memory. On the other hand, in case of quantum computing, the paradigm is a bit different. There are 2 main paradigms right now. One is using the annealing hardwares, and the other one is using quantum circuits. Here are 2 examples for these approaches. So the quantum annealing approach, which is basically supported by the D-Wave set of hardwares, in this case, the task is that you have a problem defined. Then for that problem, you have to formulate in the form of some sort of objective function. And the minimum value for this objective function will represent the optimal solution for your problem. And once you have formulated this sort of your problem in an adequate format, which is accepted by the D-Wave hardware, so this is typically some sort of quadratic model, then you can pass that description onto the hardware, and through sampling and solving, the optimal solution is found by the quantum hardware. So these are the two stages here. So first we are formulating, and after that we are sending the problem to the hardware for processing. And this figure comes from the DV documentation. If you take a look at that given link, then you will get very detailed instructions on how to formulate your problems. The other approach is the usage of quantum search suites. This is very similar to classical search suites. You have quantum bits, qubits, participating in the system, and you have different operators called quantum gates, which modify the phase of the qubit or perform some sort of transition on the qubit or a number of qubits in the search suite. And finally, after performing this, then you can measure the state of the different qubits in the system. And there are much more implementations for this approach. So here you can see at least 5 of them, but there are many more different implementations. And most of these are actually usable, so you can start experimenting with this if you want to. This is a brief summary of the hardware providers. As of today, D-Wave, Amazon Braket, IBM, Azure, and Google is offering already hardware. Most of these are publicly available. Most of them are free to use, but in some cases, mostly in case of Azure and Amazon, you have to pay for accessing these resources. But for experimenting, it is really nice. In order to use these resources, you need to use SD keys, and frameworks are available as well to ease the usage of the quantum computers in different scientific domains. Most of the SD keys which are offered are based on Python, so they can be easily used, for example, in Jupyter notebooks to develop an application. And most of the examples are based on this approach. There are also a number of frameworks which help you to exploit the possibilities or experiment with the possibilities of quantum computing in machine learning, quantum chemistry, and so on. Very detailed examples are available with very detailed description on what is happening in the background and why it is useful, or later why it will be used for when the capacity of the quantum computers increases. Okay, and in order to make the quantum resources easily accessible for users, we have decided at Stucky to create a reference architecture which contains everything which is needed to access such resources. And this is the architecture. As you can see, we have a Jupyter lab where all the necessary SD keys and frameworks are deployed. We have prepared, and we are continuously increasing the number of examples that we are providing. There is also a Spark cluster provided in order to execute a number of examples, but actually to start experimenting with quantum resources, this Jupyter component is enough. So that is already there. You can start up this reference architecture using Docker Compose or Kubernetes. So if you are going to the EOSC marketplace and you are selecting a compute resource and start up a few VMs there, then you will be able to start this reference architecture on those resources and start playing with that one. There are a number of examples included. One of these is the minimum vertex cover. Here the problem is that if you have a graph and you would like to decide which are the points, the minimum set of points from which you can access all the other nodes and all the other edges in the graph with at most one step. And we have prepared an example for this on how the processing of this problem works with the simulator and how it works on the quantum resource. And as you can see, the execution of the quantum resource, it is the red line. It is basically constant, so it doesn't depend on the size of the graph. But as the size of the graph increases, then processing this problem with the simulator increases exponentially. Another example is the Deutsch-Osch algorithm, which can decide the property of a function, which can be either constant function or balanced function, mapping to binary values. So you can decide this property of the function with one single execution, one single evaluation of this function. And how this can be used or exploited, we are offering this for interested ELKH cloud users. This is the national cloud in Hungary, and we are experimenting with manufacturing-related problems in the Coverza type project and Hungarian TKP-NKT programs, but we are also working in the Hungarian Artificial Intelligence National Lab to implement quantum support vector machines for AI applications. And a few words at the end about the AGI notebook service integration. I think you are aware of what this service is, so it is a very easy tool to access a development environment on AGI resources. And we are adding this quantum resource access to the AGI notebook. This is an ongoing work. The SDKs and the frameworks offered will be included into this AGI notebook images, and the examples can be downloaded on demand. As a result, the quantum resources will be accessible for the EOSC users who are accessing this service. The local simulator will be usable right from within the notebook server, but in order to access the real quantum hardware, third-party credentials will be needed, which should be acquired by the user, and once that is done, then the usage of the resources will be solved. And if you are interested, this is the URL to the reference architecture. You can try to deploy that on EOSC resources, and any feedback or fitting problem is welcome. So if you have something like that, then please contact me. Thank you very much.
Thank you very much, Zoltan. And because let's keep the questions to Zoltan in the coffee break, and please, our final presentation today.
Hi, I'm Themi Zamani. I'm from GRNet, and I'm here on behalf of EUDAT and the DICE project, which our use case is to integrate our services with the EOSC platform. So I would like to inform you about the DICE project, although some of you already know it because you are using our services. It is a project with 24 partners as a consortium, and the coordinator is INECA, and some of our goals is to enable a European storage and data management infrastructure for EOSC and provide generic services to store, find, access and process data in a consistent and persistent way. In order to do that, 18 providers from 11 European countries are offering 14 state-of-the-art data management services together with 50 petabytes of storage. So, I will start my presentation about the integration with some questions. Have you visited the marketplace and seen our services? Did you try to log in? While trying to log in, did you see B2 Access? Do you have a question about all the services we have, the B2 services? And have you tried to make an order? You could see that you can follow this process, and that is what we did during the first 2 years of the project. Before we start, I will say 2 words about the EOSC, which is the environment for hosting and processing research data to support the science, and about the components of the EOSC. The first one is the EOSC Core, which is the set of services providing the means to discover, share, access, and reuse data and services. It is the EOSC interoperability framework, which it is a generic framework providing common understanding of the requirements to support the integration. And then we have the EOSC Exchange, which is the set of services complementing the EOSC Core. When we're referring to EOSC Core, we all know these basic services. The AI, which is responsible for the authentication and the authorization of the users. The resource catalog, where local, national, and international providers can advertise their services, and user can start searching and find services that meet their needs. There is also the help desk, where you can ask and find information about the services. The monitoring, which checks the status, the availability and reliability of the services. The accounting, which is responsible for the usage of the services. And the order management, which manages the ordering of the services. At the other side, we had the EUDAT, which is offering to research communities and researchers a set of integrated services for data management. The EUDAT services address needs in various stages of the research data lifecycle, like in data discovery with B2Find, data access and sharing with B2Share and B2Drop, data management and preservation with B2Handle and B2Sift. On top of them, we have a user management tool, which is the B2Access. Behind the scenes, we have also developed and deployed a number of services to support what's called the CDI operational and collaborational tools, which we have the operational tools that cover the whole life cycle of services for planning to delivery, like the DPMT, the monitoring, the accounting, the catalog we have, our own help desk, and the B2Access, which is responsible for authentication. And at the other side, we have the collaborational tools, which help us advance the automation, integration, and interoperability with external services. So, from the one side, we have the EOSC services, EOSC core services, and the other hand, we have the EU.CDI operational and collaborational tool. You can see that we have services that have common functions with the EOSC core. So, what we see is that we have the B2Access for authentication, our catalog that can connect with the resource catalog, our help desk that can integrate with the help desk, monitoring, accounting, and the TPMD for the monitoring, accounting, and ordering integration with the EOSC core. And this is what we do, is use these services as the integration path to the EOSC. So what we did, we started following the guidelines. So we followed the requirements of the guidelines in order to integrate our services with the EOSC core. And that, what did, is to help us be part of the EOSC exchange and put our services in EOSC. If you want a picture of what type of integration we've had finalized and what is in testing and waiting for integration, we have integrated the help desk, the order management, our catalog with the service catalog of EOSC, and we are currently testing the monitoring service and the accounting service, the accounting for services in EOSC. We're also waiting for the final guidelines in order to add B2Access to the EOSC Federation, EOSC AAI Federation. How we did it? With our tools, like this PMT, which is our service catalog. It is easy to use. From the beginning of the project, it has adopted and implemented the EOSC profiles, which are available in EOSC. And now, it's in EOSC profiles number 4 specification. It is integrated to EOSC by following the guidelines. And what the advantages of this catalog is that it allows us to curate the content of the services independently of the process they follow in the EOSC catalog. At the same time, we can advertise our services via one click, update the information, and reach a wider user base. The B2Access, it's our own authentication and authorization infrastructure. It is a federated cross-infrastructure authorization and authentication proxy for user identification and community-defined access control enforcement. It follows all the necessary specification and interoperability guidelines. It is part of the EOSC AI, and it supports a number of communities in EOSC. It is compliant also with the ARC blueprint and the REFIT certifying. And we also have the help desk, which is the communication resource that serves as a communication channel for support and problem resolution. And it manages all the incidents we have in EU data and DDI specific services, transferring them to the appropriate support team. The EU Data Help Desk was one of the first help desks that was integrated in the EOSC, and currently we're receiving all our orders and problems or questions via our help desk. The EU data monitoring that we have is also ready to connect to the EOSC monitoring. We were waiting for the final the guidelines were just released, and we're waiting for the validation of our data so to connect to the EOSC monitoring. So, based on all this, what we did and what is our use case? We managed to add a new path for users to reach our services and follow all the necessary steps in order to order and start using them. So a user may find our services in the marketplace, see all the details that we have about and the description of the services, log in to the marketplace via B2Access, which is also the authentication service of EUDAT, and then start making an order and give them support via the help desk through the EOSC help desk. That's all from me. Thank you.
Thank you very much. Because I think it might be a good time to everybody get coffee. So maybe not have questions here, we can have them in the coffee break. But I would like to thank once more all of our speakers. I think that was a very tight set of information in 130 slides plus what Carl had. So I hope you enjoyed the session as much as I did. It was a very wide range of ideas of use cases and services available in EOSC. So thanks a lot for everybody.